Okay, guys. So my phone died, and I just wanted to continue instead of starting all over. Okay. So remember, full revolution is 2 pi r, but we're gonna assume the arc lengths are the same as the radii. Okay. So it's one, a unit of one. Okay. So if you look, remember we said a full revolution would be the same as 2 pi r, or just 2 pi, considering our radian would be one. So it's approximately a little bit over 6 radians. Okay. So if you notice, I broke it down. This is not a perfect circle. You can refer to your book, but I'm just going to explain it. Okay. You have to imagine the lines are perfect, the circle is perfect. So we have 1, 2, 3, 4, 5, 6, and then just a little bit over 6. Okay. So I'm going to add to this. So we said a full revolution would be 2 pi. So half a revolution would be pi. And a quarter revolution would be pi over 2. And 3/4 would be 3 pi over 2. Okay. So you can kind of break it down. And then I'm going to explain a little bit further what quadrant 1, quadrant 2, quadrant 3, and quadrant 4, what kind of center angles could be contained in there. Okay, so let me draw you another picture. So this would be quadrant 1. Okay, quadrant 1 right here. And we know that it only contains angles anywhere from 0 to pi over 2. Okay, so, and I shouldn't say exactly 0 because it's anything in between. So, oops, my theta. Anything between 0 and pi over 2. In quadrant 2, we would hold any angle between, of course, pi over 2 and pi. Okay. So remember, it's always minimum and then maximum, okay? And then this is quadrant 2. Remember, we always go counterclockwise. In quadrant 3, of course, we would hold anything between pi and 3 pi over 2. Okay, so between pi and 3 pi over 2. Okay, and then in my fourth quadrant, of course, we would hold any angle between 3 pi over 2 and 2 pi. Okay, and that's going to help you answer some of the questions. Okay. And of course, you can further break it apart even in between. Okay, so other equivalent fractions. Okay, but then that way you just get an idea. Again, I can break it down even in between, and I'm going to show you that with degrees in a minute. Okay. All right, so let's go to the next picture. All right, guys, I redrew a circle again. Sorry, it's not perfect. I don't have all my tools with me, but this is just to give you an idea. Okay, so now I'm going to measure it in degrees. Okay, we know that an entire revolution is 360. We know that half a revolution is 180. A quarter would be 90, and 3/4 would be 270. Okay, and then I can keep breaking it down in different increments. Okay, I can do 30 degrees. And then if I do 30 degrees, we know we're basically breaking it down in by thirds. So 30, 60, 90. I can break it down into basically, I would say half. Half would be here, and that would be 45. Or if I do it this way, so now I have a quarter. Okay, so I could break it down over here, 15 degrees. So you could just keep breaking this down however you want. Okay, and everything is in reference to 360, so you could break it down. So 45 would be an eighth of 360. Okay, so that's my fraction. This will help you for when you need to draw, and you could just find equivalent angles, equivalent radians, and whatnot. Okay, so that'll help you with that. Okay. All right, so I'm going to give you a couple of examples now, and then you can try some on your own as well. All right, boys and girls, so I'm going to try number 13 with you. And in number 13, they're actually asking you, determine the quadrant in which each angle lies. Um, the angle measure is given in radians, okay? So it's up to you if you want to rewrite it as an angle or you just want to leave it this way and just figure out what quadrant it is, okay? So what I do is I kind of use pi over 2 as my reference angle, okay? So I try to see the equivalent, okay, to pi over 6, okay? So basically, if I were to multiply this by 3 to the numerator and the denominator, we end up with 3 pi over 6. And clearly, pi over 6 is a lot smaller than this. Sorry, I'm not necessarily trying to find the, I'm not saying that these two equal each other. I'm just trying to find the equivalent, okay? Because I want common denominators. So 3 pi over 6 is greater than pi over 6. So what that means is that this must still lie on quadrant 1, okay? So for 13a, it would be quadrant 1, okay? All right, so now I'm going to try 5 pi over 4, okay? So the good thing is I already did 13. So pi over 2, or quadrant 1 goes from 0 to pi over 2, or 3 pi over 6, right? But see how now it's 4? So I'm going to find the equivalent, okay? So this would be 2 pi over 4. Clearly, this is smaller than this. So the next one would be pi, and pi would be the same as 4 over 4. Guess what? 5 pi over 4 is still bigger than this. So that means it's going to lie on the third quadrant, okay? So this is going to be quadrant 3. All right, hopefully that makes sense. And I don't even have to change this to angles. I just leave it that way, okay? I think it's easier, or I'm okay with that, okay? If it's easier for you to change it from radians to degrees, then you can always do that, okay, and figure out where it lies, okay? All right, so now I'm going to have you try some. Okay, now I'm going to do 19 with you, and in 19, they want you to sketch each angle in standard position. Okay, so earlier I was saying that I didn't want to change my radians to degrees, but here I'm going to show you how, if you're having trouble understanding radians and if it helps you change it to degrees, then do so, and it might make things a little bit easier for you, okay? So let me show you. So 3 pi over 2, we can rewrite this as 180 degrees over pi radians. And I'm actually going to show you in the next slide how to convert these again, but here's a prelude to that, okay? So we're going to multiply our radians by 180 degrees over pi radians, okay? This is in radians. So even though it's not stated, it's there. So what happens is the radians unit of measure will cancel out, okay? And then the pi's cancel. And then 2 and 180, greatest common factor is 2, so this would be 1, and this would be 90, but it is still in degrees. So 90 times 3 is 270. Oops. So believe it or not, 3 pi over 2 is the same as 270 degrees. But you already knew that because we know that, and I'm just going to do a quick draw here. We know that this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So what our angle looks like basically from here to here, this would be our angle. And we want to make sure we draw our lines, okay? And we move counterclockwise. So we already knew that. I did this just to show you how we can convert it, okay? Just in case you're having trouble. So with that said, if this is pi over 2, negative pi over 2, because we already know, is basically just a quarter. So, but because it's negative, we would draw it down here, okay? And this right here is negative pi over 2, okay? And I actually picked the easiest ones, and I'm sorry for that. But negative pi over 2 would be this. This would be equivalent, okay? Remember, this is pi over 2, so it's just a quarter, but instead of drawing it this way, we draw it this way, clockwise, okay? All right, guys, moving on to the next one. All right, boys and girls, so now you're going to get an opportunity to practice on your own. You're going to practice doing similar problems as well as sketching, okay? So use your textbook and then come back if you have any questions.